Next up on the many-sided world of geometry program 1, we'll learn some great geometry basics, like points, lines, planes, and space. We'll cover postulates and theorems too, and throw in a bit about angles. Stick around to learn about endpoints, segments, and some real acute angles. All this and more on the many-sided world of geometry, program 1. This program is made possible in part by Microsoft Windows Media Player, the all-in-one player that lets you listen to music, watch videos and movies, copy CDs, and hear internet radio stations from around the world. WindowsMedia.com, your guide to audio and video on the web.
Over the course of this information-packed program, we're going to help you learn all about lines, rays, angles, theorems, postulates, proofs, triangles, and a bunch of other geometric stuff. Then, along with some cookies, toothpaste, a little cash, and a note from home, we'll fit it all into a polygonal care package and ship it off to your brain.
Now, we know that geometry can be a really rough ride at times. The standard deviants have scoured the nation for all the basic geometry material you need to know, and then hired some great geometry instructors to help us. You can count on us to simplify this stuff and make it easy to learn, easy to remember, and just a little bit enjoyable. That's our job.
One of the biggest moments in geometry occurred back in the 6th century BC, when Pythagoras proved the Pythagorean theorem. That's a good thing, especially because the Pythagorean theorem was named in his honor.
Pythagoras was my friend for 37 years. We would discuss things for hours on end. I think we met in the 6th century BC. I knew the man like I knew the back of my hand. Oh, and one more thing. Pythagoras knew math.
Part 1. Geometry Basics.
Geometry, like most forms of math, dates back to ancient times. A lot of what we study in geometry today was discovered and written down by ancient Greeks, guys like Pythagoras and Euclid. Actually, the type of geometry that is studied most in schools today is called Euclidean geometry, after old Euclid himself.
Euclid based his theories about geometry on one key idea about parallel lines, which we'll learn later in this program. For now, just realize that geometry has to do with shapes, the parts that make them up, and their relationship to each other.
So geometry is a different kind of math than algebra, and it requires a different kind of thinking. It's not so numbers-based, it's more visual. To get you geared up for it, we're going to spend some time thinking about geometry.
Section A, Thinking about Geometry.
In geometry, we use two kinds of reasoning, inductive reasoning and deductive reasoning. We use inductive reasoning when we recognize patterns and make observations. Then, as we examine why these observations happen, we use deductive reasoning.
Here's an example of inductive reasoning. Let's say that your friend picked you up in a red sports car this morning. And over the past few months, you've observed this same pattern. Every morning, your friend picks you up in a red sports car. So you guess that tomorrow morning, not only will your friend pick you up, but he'll be driving a red sports car, and not, say, an elephant or a van. We expect this because inductive reasoning leads us to expect the observed pattern, your friend in the red sports car, will continue.
In geometry, we use inductive reasoning when we recognize details about different shapes and the parts that make them up. As we encounter different shapes over and over again, we'll see certain patterns begin to emerge. Recognizing those patterns is what inductive reasoning is all about.
Deductive reasoning is used when we examine the reasons why something happens. Deductive reasoning has been used by everyone, from Sherlock Holmes to Batman. Don't worry, it's not just for crime fighters. We all use deductive reasoning when we check out our inductive observations. We'll use logic and previously accepted or proven facts, because we can't accept an observation as true until it's been proven. We'll see deductive reasoning in action later on when we solve proofs.
While inductive reasoning leads us to anticipate that your friend will pick you up in a red sports car, we could only prove that he'll pick you up with deductive reasoning. We'd have to know that he left his house on time, he remembered where he'd parked his car started, he remembered how to get to your house, and you were waiting at the door, plus a bunch of other things. The point is, with deductive reasoning, we examine what leads up to the observation.
Now that we have an idea of how to approach thinking about geometry, we can begin speaking the language of geometry.
Section B. Points, lines, planes, and space.
What are space, planes, and what?
Points, lines, planes, and space are the building blocks of geometry. Why? Well, geometry is a visual math. We're going to be seeing a lot of different shapes and looking at how they're put together. Then we'll look at the relationships between the parts of one shape and another.
In geometry, it doesn't get much more basic than a point. A point is represented by a dot. It has no length, width, or self-esteem. It's just a placeholder, really. We usually name a point with a capital letter, such as B, C, or X.
A line in geometry has no width, but its length extends infinitely in two directions. Usually, we name a line with a lowercase italic letter L, or by naming 2 points on the line and topping them with a 2-arrowed symbol. Collinear points are points which lie on one line, such as A, B, C, D, and S, T, U.
A ray is a lot like a line, except it begins at one point and extends infinitely in one direction from that point, like this single ray from the sun. As we see, ray AB begins at point A and goes through point B without ever ending or getting thirsty. We write ray AB as AB with a single arrowed line on top.
A segment is the part of a line or ray that is between 2 points. Here, segment TE begins at point T and ends at point E. We write segment TE as TE with a solid line above it.
In ray AB and segment TE, A, T, and E are the endpoints. So a ray has one endpoint and a segment has 2 endpoints. By the way, a line doesn't have any endpoints. It just goes on forever, like True Love and Seinfeld reruns.
Okay, that's a lot of different ways to talk about lines and stuff. Now that we know all that, let's talk about ways to split them up.
First, there's betweenness. We say that point R is between points T and E only if T, E, and R all lie on the same line, and together TR and RE equal TE. So let's say that the measure of segment TR equals 5 inches, and the measure of segment RE equals 3 inches. Then TE equals 8 inches. That's really just a complicated way of showing that R is between T and E.
A midpoint is the exact middle of a segment. Not a little to the right or a little to the left. The exact middle. O is the midpoint of segment TE. When a line, ray, segment, or plane, which we'll define in a minute, crosses a segment at its midpoint, it's said to bisect the segment. Not dissect, but bisect.
Let's note 2 things. 1, lines and rays cannot have midpoints because they're infinitely long. And because they're infinite, there can't be a middle. 2, when a segment is bisected, its halves are what we call congruent.
The terms congruent and equal are very important in geometry. We use them in similar but different ways. So now, let's distinguish between their usage.
Let's say that segment TE is 2 meters. It has a midpoint, O. So its 2 halves, segments TO and OE, have the same length, 1 meter. To put this in terms of geometry, we'll say that the lengths of segments TO and segment OE are equal. 1 meter equals 1 meter. However, the segments themselves, not their measurements, are congruent. Segment TO is congruent to segment OE. This symbol means congruent.
Congruence is very important in geometry. Not only can the measurements of segments be congruent, but so can the measurements of angles, triangles, and other polygons we'll talk about later.
We've covered all the basic line definitions that we'll need, so let's move on to planes and space. When I say planes and space, it's nothing like the space shuttle or some sort of star chariot. Oh no, we'll be talking about something different when we refer to planes and space.
Think of a flat surface like this tabletop and imagine extending it infinitely in all directions. This is a plane, which we'll label with a capital letter P. All the stuff we've talked about so far, points, lines, rays, and segments, all exist in a plane somewhere.
Remember collinear points? Well, now we have coplanar points. These are points that lie in the same plane. Points A, B, C, D, and E are all coplanar points in plane P.
Coplanar lines are, as you'd expect, lines that are on the same plane. Here's an example of two coplanar lines, line L and line M, that extend infinitely without crossing. These are parallel lines. This is how we write line L is parallel to line M.
If lines aren't parallel, they cross and are called intersecting lines. The one point at which they cross is called the point of intersection. There's no special notation for intersecting lines.
Now let's talk about space. Space is a set of all points in 3 dimensions. We experience space every day. It's all around us. We're in it right now. It's here, even here, possibly even over there.
Now, points, lines, rays, and planes all exist in space. Here are 2 lines in space that'll never intersect. Notice also that they're not parallel. We call these lines that never touch skew lines. Notice that lines in space which are not coplanar will never meet. So if lines meet, they must be in the same plane. Likewise, parallel lines are always coplanar.
So let's review our definitions. A point has no length or width. A ray begins at one point and extends infinitely in one direction. A line extends infinitely in both directions. A segment is the part of a line or ray between 2 points. A midpoint is the exact middle of a segment. When a line segment, ray, or plane crosses a segment at its midpoint, it's said to bisect the segment. A plane is a flat surface that extends infinitely in all directions. 2 lines on the same plane are called coplanar. 2 coplanar lines can either intersect or be parallel. And space is the set of all points in 3 dimensions. That's it.
Now that we have our basic definitions down, let's move up to the next.